Hello, fellow seekers of knowledge and unveilers of the unknown. I'm Ernis, your guide through the winding corridors of cutting-edge research. Today, we're not just reading a paper, we're stepping inside it. Prepare yourselves for a journey into the world of LLMs and a surprisingly simple way to make them even smarter. Have you ever considered the idea of a model teaching itself? No rewards, no complex algorithms, just pure, unadulterated self-improvement? It sounds almost too good to be true, doesn't it? But that's precisely what this paper, Online SFT for LLM Reasoning, Surprising Effectiveness of Self-Tuning Without Rewards, explores. Now, before you get lost in a nebula of jargon, let's break it down. Imagine a cosmic library, each section holds a key concept. Our journey begins in the hallowed halls of Online Supervised Finetuning, or OSFT. The core idea, it's stunningly simple. The LLM generates its own responses and is immediately fine-tuned on that self-generated data. Think of it as the LLM having a conversation with itself, then immediately taking notes and trying to do better. No external rewards, no gold star for good behavior. Now, let's build our memory palace. Picture a grand foyer, where our LLM stands, ready to tackle a complex math problem. This is our prompt, a carefully crafted question designed to test its reasoning skills. From the foyer, we step into the first room, self-data generation. Here, the LLM takes a crack at solving the problem, guided by a sampling temperature. This temperature controls how creative or how conservative the model is with its answer. A lower temperature means it sticks closer to what it already knows, while a higher temperature allows it to explore more unconventional solutions. The paper's authors discovered, quite unexpectedly, that tweaking this temperature is absolutely crucial. This part is a revelation. You see, the authors found that the untuned model's performance is incredibly sensitive to this evaluation temperature. Pass at 1. Accuracy, which is the probability of getting the correct answer on the first try, peaks at low temperatures. But pass at 8, which gives the model 8 attempts, benefits from slightly warmer temperatures. It is like the model is peaking at different temperatures and these peaks can be combined. From self-data generation, we move into the second room, supervised fine-tuning. Here, the magic happens. The LLM takes its self-generated answer, compares it to its own internal knowledge, and gently nudges its parameters to align better with what it already knows to be true. But there's a twist. The authors discovered that to get the best results, you need to use different temperatures for generating the data and for training on it. It's like carefully adjusting the recipe while baking a cake. Too much heat, and the whole thing collapses. The stable regime occurs when the sampling temperature is lower than the training temperature. In this case, there is certainty of the model's existing preference. Fine, yeah, I guess. Look, the point is, this paper is a big deal. Now, you might be wondering, why go through all this trouble when we already have reinforcement learning with verifiable rewards, or RLVR? That's where things get really interesting. The researchers compared OSFT to a strong RLVR method called Group Relative Policy Optimization, or GRPO. And guess what? OSFT achieved comparable downstream performance on challenging mathematical reasoning tasks. It's like discovering that a bicycle can keep pace with a race car on a winding mountain road. I know, it sounds almost too simple to be true. But the authors ran extensive ablation studies, carefully tweaking the parameters and comparing the results. And the conclusion is clear. OSFT is efficient, robust, and surprisingly effective. Now, let's stroll into the final room of our memory palace, the big picture. Here, we see the true significance of this research. The authors argue that OSFT works by enhancing the model's existing preferences, its latent knowledge, learned from pre-training. It's like polishing a rough diamond to reveal its hidden brilliance. Think about it. Instead of relying on external rewards or complex algorithms, OSFT taps into the LLM's own internal resources. It's a self-help program for AI. A way for these models to learn and grow without constant human intervention. In conclusion, this paper presents a compelling case for OSFT as a simple, efficient, and surprisingly effective method for improving LLM reasoning. It's a testament to the power of self-tuning and a reminder that sometimes the best solutions are the simplest ones. So, go forth, explore the mysteries of OSFT, and remember to always question the conventional wisdom. Because in the ever-evolving landscape of AI, the greatest discoveries often lie just beyond the edge of what we think is possible. Until next time, keep exploring,